up, dudes? We're going to be covering rational functions 2, vertical asymptotes. And I know that there's going to be some jokes about some bad words using the word asymptote. And I say to that, don't do it. Seriously. So, hold on to your asymptotes, and let's get moving on to the next problem right here. Alright, 1 second. Let me just turn on my cell phone so that I'm not bothered by any convenient thing. There we go. Alright, let's read it. When the race was over, the hare simply could not believe how fast he lost, or how he could have lost to the slow tortoise. It didn't make any sense, and on top of that, there was a new motto that was heard by all the slower animals in the forest. Everywhere he went, and everyone he talked to would always be sure to remind him that slow and steady wins the race. The hare was disgusted in losing, not only blah 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 wah 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 wah. Good googly moogly. This is a long explanation for this thing. You can read it if you want. It's a cute story. Basically, the hare studies physics, and he figures out that rate. Oops, there we go. Okay, this, and I want the small pen, and I'm going to do blue. And rate is equal to distance over time. You knew that. I mean, if you drive at 50 miles per hour, you're dealing with miles per hour, distance over time. If you want to solve for t by itself, well, you can multiply both sides by t, and you get RT equals D. You also get that t all by itself means you divide by R, so you get t is equal to D over R. And then what he did is he made a little table, and he calculated out the time it would take for all of these different animals, given their rates. So this is the rate of a rabbit, rate of a chicken, rate of a spider, tortoise, three-toed sloth, as opposed to a two- or four-toed sloth. I don't know if that's any different. And then a snail. And then he calculated the amount of time it would take for them to run a distance of 1 mile. So for the rabbit, he basically plugged in t is equal to 1 mile divided by 35 miles per hour. Now, since I got a fraction over a fraction, I can kind of make this hours over miles. I'm dealing with just the units here, and then this mile cancels out with that miles, and then my time is in hours. So, I mean, that's the correct units at least. What is 1 divided by 35? Well, to be honest with you, it's 33.33333. How did I know that? I think it is, anyway. I actually made a little table, and I know I cheated, but the rate of the rabbit, and I actually kind of did this table a little bit backwards. I put the snail the first, and I did the rabbit over here, just because I wanted to have something that goes from slowest to fastest, or the smallest rate to the biggest rate. So anyway, my table is a little bit different from theirs, but I used this equation to calculate it out. So I said the distance is 1 mile, 1, 1, 1, 1, 1. And then I plugged in the information they gave me here, and then I said, okay, this cell right here is equal to the distance divided by the rate, as in this cell D3 is equal to B3 divided by C3. And then same over here, and so this is telling me the rates of the different things. What do you notice about this? Well, I noticed that as this rate gets really small, this time gets really big. It kind of explodes. You see what I mean? What I mean by explodes is it doesn't literally explode, it just kind of gets big. I could graph that. I think I did here. And you can see that as your time gets small, the y value gets really big. Or as the rate gets really small, the time gets really big. So that's kind of how that graph would look. Alright, are we cool with that? So I think that might be, yeah, that's what I want to talk about for now. I want you to just kind of experience that, and then let's move on to the next video.